All right, welcome to a lesson on 8.2, which deals with composite figures. I'm going to go through the lesson, and then there's going to be some handouts for you to finish on the end, at the end of the lesson here. So let's just get into what a composite figure actually is. If I were to ask you what this shape is, everybody would say a rectangle. And if I were to ask you what would represent a rectangle in real life, like what in real life would be a rectangle, you might say a piece of paper, maybe a cell phone. You could come up with all kinds of stuff, a laptop, a door. But if I were to give you a shape like this, you may say, oh man, I don't know what that is. I've had a lot of students in the past say it looks like the side of a washing machine or an arcade game. Looks like an ATM machine. In all actuality, I got this from a yard in a subdivision. So here's the yard, and you can see how these are the same. This is called a composite figure because it's not a rectangle or a simple shape, but it's a shape that we can break up into simple shapes. You see the rectangle in the bottom? And if I were to go like this, do you see how that's a triangle and now another rectangle? So you can break a composite figure, which is more than one simple shape, up into its simple shapes, and then you can work with it. So as a definition, you can pause this and copy it, but I'm just going to go through it quickly. Composite figure is a figure made up of two or more simple shapes. And by simple shapes, we're talking about squares and rectangles, things that we know formulas for. So I know that the area of this right here is length times width, but I don't know what the area of this is. But when I break it up, I know this is length times width, and this is length times width, and this is base times height divided by 2, because they're all simple shapes that I know the formula for. Some of the facts or characteristics is to determine the area, break the shape apart like we did with that yard, figure out all the individual areas, and then add them back together or subtract them depending on the question. But for a perimeter, just make sure you calculate the outside. Don't include the middle, just the distance around the outside. And sometimes you have to find unknown lengths, okay? Sides that aren't labeled, you have to find them in order to keep going. So pause the video, you can copy this out. Examples, a donut is a circle with a circle cut out. A phone has keys on it and a screen. A piece of paper that's hole punched is a good one because it's got circles cut away. A door's got a window cut out, and even if you are like me and you pick up a pizza to bring home, it always seems to be a slice of pizza missing. It's like a triangle missing from a circle. Some things that are not, a semicircle is not a composite figure. It's just half of a circle. You take the formula, divide it by 2. A window, a plain old TV. These are things that are not composite figures. I'm not going to go too far into this, but it basically asks with these two shapes, what's the same with both? And here's what I say. You've got 2 semicircles here, and you got 2 rectangles. The difference is this shape, you add a semicircle on top of a rectangle. In this one, you cut it away, okay? So this gets cut away from a rectangle. If I were to color that in, then this would be a rectangle with a semicircle cut away. So the question just said, what's the same for determining the area of each of these? Well, for each of them, you've got to get the area of the rectangle and you've got to get the area of the semicircle. That's basically what you got to do. Find the area of the semicircle, find the area of this rectangle. Find the area of this rectangle and find the area of the semicircle. But what's different is in figure 1, you add them together, whereas in figure 2, you subtract the semicircle from the rectangle. Which of the 2 figures is larger? Well, it is figure 1. It's larger by a circle of radius 3. So you see here how this is bigger. If I were to go right here, I draw this circle in here, and I say, okay, well, you are going to have a solid fill, and I'm going to make it that color. So do you see how these 2 shapes are the same now because I added a full circle in here? This is bigger by a whole circle. Just like if I were to go here and cut this away. See how these 2 shapes are the same now? So this is bigger by a whole circle. And the funny part is, which has the bigger perimeter, the distance around the outside? And this is always a good argument. But when we go like this for the perimeter, this perimeter is down, over, and up. Just like this one is down, over, and up. And right now we're the exact same perimeter. But don't get confused here, because this, you have a piece that goes up and over, whereas this one is the exact same piece. I just cloned it and I brought it over here, but it's just going the other way. These two perimeters are the same. The distance around the outside is the same. This one goes on the outside, this one goes on the inside. Yes, this is a bigger area than this one, but the perimeters are the same. It takes the same amount of fence to go around the outside of both of these, which is kind of deceiving. So down below, I'll just put that in for you. Both figures have the same perimeter. Figure one has the greater area, but the perimeters are the same. So given this shape here, if I were to ask you to calculate the perimeter, just add up all the outside, and I got 50 centimeters. Okay, 7 plus 14 plus 7, 3, 4, 8, 4, 3. Add them all up, you get 50. But when we calculate the area, we do each individual rectangle. I broke it up going down here, and I've got 1, 2, 3 rectangles. So my first rectangle is length times width, which is 3 times 7. Same with my second rectangle, it's also 3 times 7. But here's where it comes in, that unknown side. My third rectangle, I need to know what this side is here. I need to know what this distance is right here. And if this whole side is 7 and this is 4, I would need 3 more in order to total this 7. I'm missing 3 to make these equivalent. This has to be 3. So I have 3 here by 8, I get 24. And when I add them all up, area total, I get 66. Okay? You guys try this one and then check your work after you're done and see what you get. So pause the video, see if you can break it up this way, find the area of these 3. Okay, welcome back. The area of the first one was 12, 4 by 3. The area of the second one, 4 by 3. And then this one is a 14 by 3. Same distance by 3, 14 by 3, I got 42. When I add them together, notice we get the exact same, okay, which we should. The last one is this, and just to kind of show you here, you've got this small rectangle inside a bigger rectangle. So I'm just going to take this out of here for a second. I'm going to draw my first rectangle. So the way we're going to do this is we're going to figure out what the area of this big rectangle is right here. And I'm going to go solid fill and make it gray there. So figure out the area of this real big rectangle. But then what we're going to do is we're going to figure out the area of this small rectangle, and I'm going to make sure to go and make this a solid fill of white, and I'm going to move this to the front. So when I bring this on top of the other one, I'm now going to put it here, and do you see how what's left is the exact same gray area as up here? What I'm going to do is figure out this area, the big gray one. I'm going to figure out the small white one, and I'm going to subtract the white one from the gray one. So the area of the big rectangle right here, this gray one, is 7 by 14, which is 98. This one here, when you go up top, is a 4 by 8. So I calculate it to be a 4 by 8, and I get 32. And when you subtract, you also get 66. So we're cutting this one away. So 66 is your answer. Okay? So that's it for composite figures. Now what you're going to do is you're going to do a couple worksheets for me here. The first one, I want you to figure out the unknown sides, get all the unknown sides, and then get the perimeter. The next, I want you to find the area. Cut the triangle away from the rectangle, add the semicircle on top of the rectangle. Okay, so find the areas of each of these figures. Then you've got a couple pages, first one and second one, that you're going to find and show a little bit of work for. I will post these solutions, but every one here is either perimeter or area, and it involves you finding unknown sides and breaking it apart to see what you come up with. So hopefully that helps. Most of you saw this lesson in class, but I thought I would just post it just in case you wanted to recap.